Alright, these notes are on finding the domain of a composite function. We looked at domain of a composite function on the notes when we did composite functions, but I wanted to look at some that had some added restrictions. The ones that we looked at in our notes did not have those added restrictions, and these ones came up in math space. So the domain of our composite function, f of g of x, is the set of all those inputs x in the domain of g, for which g of x is in the domain of f. So when we're looking at this, we have to start by looking at what we're inputting into the function to make the composite function. We have to look at, are there any restrictions to that? So we have to find the domain of g. And then we're going to make the composite and see if there's any additional restrictions based off of that composition. So we're going to work a couple examples. Some of them I may have to go to another piece of paper for. This first one, we're going to look at first, these are our two functions. So thinking about their domains, the domain of f here is all real numbers. Anything can go in there, there's no restrictions. Everything works. And if you're not sure about that, go back to the parent function, the quadratic, and there's no restrictions on our domain there. Now, looking at the g of x, there are restrictions. It's a square root, so it can only be positive. So we have to think about when would this be negative, and that's going to be negative whenever we're less than negative 2, because if we're less than negative 2, then we're going to have a negative under our radical, and we're in the real number system, we're not taking square roots of negatives. So our domain here is negative 2 to infinity. And it can be negative 2, because a negative 2 gives us a 0. We can take the square root of 0. Again, you can refer back to the parent function if you would like. So now that we know those two, we're looking at our function, our f of g of x, our composite function there. So we're plugging in the g. So that already has a restriction. So we have to keep that restriction in mind because that's going to be part of our composition. It's going to be the restriction on our composition as well. So right now we know for sure we have to be negative 2 or greater. So looking at the composition, so then you need to do the composition. So the f of the g of x is when I'm plugging in the g of x, my function f. So square root of x plus 2 squared minus 2. So then that is x plus 2 minus 2, because whenever you square root, that undoes each other. And the 2's cancel. So our composite is x. Now we can start to think, are there any restrictions on that? And there are no restrictions on x. That's linear, we can put anything in there. So the domain for our composite is just our input. So negative 2 to infinity, that's our domain. Now what about if we do it the other way? We're looking at the g of the f of x. So first we're going to look at f, because we're plugging that in. And there's no restrictions to f. So right now, we have no restrictions. But we still have to do the composition to make sure there's not any restrictions caused by doing the composition. So the g of the f of x is equal to, we're plugging in to our radical, replacing x with our f. So that's x squared minus 2 plus 2. We're cleaning that up. That's the square root. These cancel out. Square root of x squared, which is x. So there's no restrictions to that either. So the domain for that composite is negative infinity to positive infinity. So looking at that, we can say that it is all real numbers for sure. So that's going to be the domain for the g of the f of x. Now let's take a look at number 2. So number 2, I'm actually going to go to another piece of paper because this is a little bit more of an involved problem. So we have two functions. We have our f of x equal to 5 over x minus 1. That does have a restriction. X cannot be 1. That one has a restriction we have to consider. And then we have our g of x, which is 4 over 3x minus 2. And it also has a restriction. X cannot be 2/3. Now, sometimes we forget how we get those restrictions. How do you determine something is restricted? Remember, your denominator cannot be 0 because that's undefined if our denominator is 0. So to make to make sure that our denominator is not going to be 0, we get 3x minus 2 is equal to 0. You set that equal to 0 to see what will make it 0. So there we go. That's where that restricted value. X cannot be 2/3 then, because that would make our denominator 0. So let's go ahead and then take a look at our composition. So we'll start with the f of the g of x. So in our function f, we are replacing x with g of x. Now we have to clean this up. Well, to be able to take care of that denominator, we need to have common denominators so we can subtract those fractions. So 4 over 3x minus 2 minus, well, make 1 into something with a common denominator, just make it x minus 2, 3x minus 2 over 3x minus 2. So that's equal to 1. Same thing as 1. Now I can put all this together, but keep in mind if I distribute that negative, that's often when we make a mistake. So I'm going to put all that together. So then I have 5 over 4 minus 3x plus 2, because I'm distributing that negative, over 3x minus 2. And I clean that up a little bit more. 5 over 6 minus 3x over 3x minus 2. Now, can't have that compound fraction, so I need to get rid of that denominator. So I'm going to multiply by the reciprocal, both the top and the bottom. Did the bottom there. Here I'm going to do the top, same thing. And then this cancels out on the bottom, so we have 1. So we're left with 5 times 3x minus 2 over 6 minus 3x. Remember, this 5 is over 1, so we're just distributing 5 to our numerator, which makes it 15x minus 10 over 6 minus 3x. So we have to decide, is there another restriction there? Well, there is. There's a restriction of 2. X cannot be 2. So we have 2 restrictions. X cannot be 2/3 and x cannot be 2. So I'm going to write that over. X cannot be 2/3. X cannot be 2. So that will help me with my domain. So my domain is negative infinity all the way up to 2/3. Can't be 2/3. Then I can be anything between 2/3 and 2. I can't be 2/3 and I can't be 2, but I can be everything else. And then I can be anything from 2 up. So that is our domain of that composition. Now what about the other way around? All right, the other way around. Let's erase this. So now, instead of doing the f to the g of x, we're going to do it the other way. We are going to do the g of the f of x. So I'm plugging into g f of x. So 4 over 3 times 5 over x minus 1 minus 2. So all I did was plug in the f into g. I'll multiply that bottom real quick, just to clean it up a little bit. 4 over 15 over x minus 1, and then that's minus 2. So just like on the example I just said, we've got to find a common denominator. I need my denominator here to be x minus 1, so I need to multiply the top by x minus 1 is also. Now remember, there's a negative there, so don't forget about it. So, numerator of a big fraction still 4, haven't touched that yet. The denominator is now 15 minus 2x plus 2 over x minus 1. And then I can clean that up a little bit. 4 over 17 minus 2x over x minus 1. Now, to get rid of that denominator, just can't have that fraction with the fraction, I have to multiply by the reciprocal. Top and bottom. Can't do something to the top of that fraction without doing it to the bottom. Now on the bottom, it cancels out. And on the top, we end up with 4 times x minus 1 all over 17 minus 2x, which I can clean up to 4x minus 4 over 17 minus 2x. So I'm looking for restrictions, more restrictions. We already had one restriction way up here. Remember we had that restriction, x cannot be 1. Now to see if there's another one. So if you can't see it, you got to set it equal to 0 and solve. X cannot be 17 over 2, because if it is, then our denominator will be 0. So we have two restrictions. X cannot be 1, and x cannot be 17 halves. So, domain, negative infinity to 1, 1 to 17 halves, and then 17 halves. And that would be our domain for the g of the f of x. All right, now going back, we will look at problem 3. In problem 3, we have restriction here, x cannot be 2. Restriction here, x cannot be 0. So when I'm looking at the f of the g of x, I already know. Plug it in a g. X cannot be 0. So that's one of my restricted values. Now I'm going to plug in g to my f, common denominator, so 1/1x minus 2x over 2. So I'll put this as an x, so I can multiply that up and bottom. Which then equals 1/1 minus 2x over x. Oh, sorry, that should have been an x. I need it to be a common denominator. And then I need to multiply by the reciprocal. Cancel, 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 cancel. So then I have x over 1 minus 2x. So I think, is there a restriction there? Well, what would make that denominator 0? There is a restriction. Oops. And that restriction is 1/2. So we had two restrictions on this one. We had 0 and 1/2. So our domain for our composition, -infinity to 0, union with 0 to 1/2, union with 1/2 to infinity. It would be anything but 1/2 to 0. And then the last one is doing the g of the f of x, so we're doing the opposite. Going to look at f, because that's what we're plugging in. F cannot be 2. I mean, sorry, x cannot be 2. X cannot be 2. So that's one restriction right off the bat. Then we're going to do our g of f of x. So 1 over x minus 2. We can multiply by the reciprocal. We don't have any adding or subtracting to do, so I'm going to easy one. Cancel, 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 cancel. And then we're just left with x minus 2. So there's no restrictions on that. But remember, we had this original restriction from the parent, so we have to include that restriction in our composition. So we can be anything but 2. So wrapping that up, find the restriction of what you're inputting. Then you do the composition, see if there's any additional restrictions, and